Good morning everyone, Jordan here from Artisan Electrics. Welcome back. And to my regular subscribers, I think you might know this familiar scene. We're back again at the Scout Hut, and this time trying to sort out the fire alarm system. As you probably saw, I posted a video about this. There was quite some issues with the existing fire alarm system that had been put in. Battery fault, no batteries. Panel is a heap of junk, nothing was connected properly, none of the manual call points connected up or anything like that. So I advised the client two options basically. One, either just give the existing system an overhaul and try and get it work as best as we can, or second, which was my recommended option, was just to remove all the existing accessories and put new ones in, put a proper new system in that I know can be relied upon, because I think a lot of this stuff that was put in has been like second-hand stuff that's been reused, and basically just reusing the existing wiring, but everything else, all the accessories, is going to be new. So that's what we're going to do today. So I've got a new panel to go in. I'm using the Apollo alarm sense system, which I've used before. They're really good quality and reliable. So this new panel's slightly bigger, so I'm going to have to just cut the wall out a little bit to fit that in. I'm going to put a special spur on here, because it should be kind of a tamper-proof spur for this, and it should be marked as fire alarm. So I've got one of those to put on. New manual call points. As you can see, these are the existing ones, they just weren't even connected. I literally just took the cover off that, and the wires are just in connectors in the back. So this fire alarm system's not been working at all for well, since it was put in basically. New detectors to go up, so basically in pretty much every room there's a detector, so I've got to replace those. There's a sounder here at the moment, and then there's one in the main hall, but the sounders are both on one sounder circuit, which is not allowed. You need to have at least two sounder circuits according to the regulations, so that there's a backup if one of them fails. So what I'm going to do is remove that sounder and try to rewire it from its own sounder circuit. I'm either going to leave it there if I can get a cable from the panel to there, or I will just reposition it above the panel here so that it's on its own sounder circuit. We've got another detector to go in up there, a heat detector to go here in the kitchen. There are a couple of cables hanging out of the ceiling there, I'm not sure what they're for. Another detector to go in the storeroom here, and then in this main hall there are two detectors on the ceiling and a call point over in the corner there. So I've got to replace those. This sounder, the existing sounders I'm going to keep because they're fine and they will work with the new panel, but I've just got to rejig the wiring a little bit on those. So it's going to be a fun job as always. I'm sure we'll hit some snags along the way. I'll let you know how I get on, and as always, if you enjoy my videos, hit a thumbs up and grab yourself a cup of tea and settle in. And if you're new, welcome. I'm really glad, and I hope that you'll subscribe to the channel and click the notification bell so that you don't miss out. So first things first, let me show you this existing panel. Slightly annoying actually, because I bought batteries for the existing panel, but now they're not needed basically. So the new panel comes with new batteries, but basically, as you can see, it's all these wires just not connected, only the sounder circuit, and even that wasn't actually connected. I think I just connected that last time I was here. So I'm just going to pull the batteries, and then there we go. Now, a few of you messaged me about how to do a battery load test, which was quite helpful. So thanks to all of you fire alarm experts who sent me those messages. Basically, using a multimeter, you can do a load test to see how much power the battery is being, how quickly the battery is going to be drained when either in standby mode or in alarm mode on these, so that you can make sure that the batteries will actually last for the appropriate amount of time. So that was quite a good little tip. So at the moment the cables are all coming in the top like this. I don't know if there's going to be enough slack to actually do anything different, or if I'm just going to have to take them into the top of the new panel, but at least if I do take them in the top, I can hopefully seal around the cables properly and stuff. This is the sounder circuit, I think. Just going to disconnect all these. All the earths have just been kind of blocked into this connector block, which is not great really. Yes, that's a sounder on that. They are kind of labelled up, these cables. So we've got, I think, 1, 2, 3, 4. So it's numbered, but they don't actually say what they do. And of course the main supply is not wired in FP cable. It's just wired in twin and earth, which I think it's supposed to be wired in FP. But you know, this job is basically making the best of what we've got. I can't be like rewiring the whole thing. That would be just far too work and far too much work and far too expensive for the client. So I'm literally just basically going to try and smarten the whole thing up and make it actually work properly, which is the most important thing. I'm pretty sure that this spare is not wired from the board in FP either. I think it's just wired in 1mm twin and earth. Yeah, no, it's just twin and earth. Oh, nice. Great. So it's kind of got a wooden box built for it. So I'm going to have to do some alterations to that. It's got this sheep's wool insulation everywhere. It's quite nice. Quite expensive, I guess, but very eco-friendly. Yeah, so just to show you, you can see this kind of wooden box has been built around it. So I think this is actually a stud that goes up, so we can't move that. These depth-wise might be okay, these noggins, so we might be able to just fix back to those. But this looks like an extra little noggin that's been put in. So I'm going to have to try and see if I can cut that and then just extend across this way, because the new panel's slightly wider. But that should be possible with a multi-tool and a bit of wherewithal. So height-wise, there's going to be a little bit of a gap on there, and width-wise it's going to go slightly wider. So I might probably leave the gap underneath, and then just draw a line here and try and cut this out. I mean, the other option would be to put a board over the whole thing and just surface mount it, I guess. That might be nicer actually. Just surface mount the whole thing. And take the cable's rear entry. Might be better. Let me know in the comments what you would do. So one of the first things I've got to do really to know what's what is just try and identify which points are on which of these cables. So to do that, what I'm going to do is go around, take off every detector and all that, but I'm going to leave so when there are two cables, I'm going to leave them in connectors like this, and then here I'm going to just connect the positive and the earth wire together, and then I go around every point and just measure continuity to see which points are on that particular cable. Then I can mark it all up and sort of make a map of the whole thing. and then once I know what's what, then that will help me to start wiring everything in properly going forward. So I got my Fluke 325 clamp meter here. I made a video about this on my Tools for Sparks channel, so if you want to know a little bit more in depth about this particular tool, go over to Tools number 4 Sparks on YouTube, and you'll find my tool channel there where you can see all about this tester. But it's great for testing continuity like this. So what I'm going to do is just connect one of these zones. So I'll start with the one that says Z1 on it. Just going to connect live and earth together like that, and then I'm going to just measure, so it's not that one because it's so close. I'm going to do it this way, but usually I will just do a measurement of I'll just connect one cable, and then I'll go from there. I'll go around all the points and just measure like that. But as this one is so close, I can just swap around. Yep, so it's that one. So this particular point is on zone 3. That's good to know. Now while I'm here, I will go and check this detector in the corridor just to see if that is on zone 3 as well, because I'm imagining that it will probably be on the same zone, but it's not. Okay, so I'm just going to start with zone 1 now. Zone 1 cable, and I'm just going to go around all the points and bell them out and see what's what. Okay, so this particular detector is on zone 1. So this is like typical of what we've been dealing with here basically. Like this is, I've just taken the cover off and this is how it's been connected up. The L2 wires have been connected, the earth's been connected, but the L1 or positive, oh wow, yeah, they've just been put in connector block basically. So completely useless, won't work at all. Stupid, absolutely stupid. The person who did this obviously had not a clue what they were doing. Now obviously knowing this place and knowing how bad everything's been done, I can't even trust the integrity of these existing cables. So what I'm doing is, as I'm taking the old points off, I'm putting the wires in connector blocks, and then once I've got one zone completely done, then I'm going to do insulation testing before I start connecting any of the new detectors up. So I'll do insulation and continuity testing just to make sure that the existing cabling is actually okay to reuse and there's not any shorts or anything like that. Because as you saw in the other video, the floor socket video for example, it's just some of these things have been done in such a bodged way that I wouldn't be surprised if one of the cables has been damaged or something. So yeah, fun. So this one's kind of been connected. Just like they got halfway through and just kind of gave up on this really. So this is what I found when I took off the core point. It's just not wired in. All they've done is put an end of line capacitor across the 2 wires and that's it. So again, very weird. So I'm going to put a new core point on here and do it all properly. So this one is in the disabled toilet. So obviously it doesn't really need a detector, but it should really have some kind of alert system like flashing light in here, so that if the fire alarm system goes off and a disabled person is in here who is deaf, can't hear the alarm, they'll see this flashing beacon. So I'm going to put a flashing sounder beacon base it's called, on here with just a dead head, so that at least there'll be a visible indication that the alarm system's going off if somebody does come in here. Right, well this place just gets weirder and weirder. So basically there are only 2 zones, zone 1 and zone 2. Zone 1 does the sort of ancillary rooms here, zone 2 does the main hall and the call point at the end of the main hall. These 2 cables, it seems, both go to here. So it's literally just 2 cables going to here. or one cable going to here and then the other cable coming back, which is just really weird. The sounder circuit does the 2 sounders, and it also does 2 wires sticking out of the ceiling in the kitchen, which presumably they planned to put another sounder there at some point but never did. So it's all just weird, but I don't get this. Why have they done it like that? I have no idea. Right, so basically I'll show you what's what. So the sounder circuit goes first to that sounder, then it goes to this point here, then it goes through to that sounder, and that's the end of line on the sounder circuit. Then the zone 1 basically goes, I'm not sure in what order, but it goes in here, probably in here, then in here, then in here, and then this is the end of line. Zone 2 goes from the panel straight through to the main hall, to the first detector here, then to the second detector up there, and then finally to that manual call point. And then that last bit of cabling, which I showed you already, literally those 2 cables just go from here to here. So now that everything's in connector blocks and kind of ready, I can do an insulation resistance test on all of this and just make sure that the cable is okay and there's no shorts anywhere before I start connecting everything up. So these cables are only going to take 24 volts. So we don't need to do like a 500 volt insulation resistance test, but we can do a 250 volt insulation test. Probably 100 volt would be fine, but I'm going to do 250, it won't hurt. There's nothing connected anyway. So I've got 200 mega ohms there on the sounder circuit between positive and negative and earth, and then let's test directly between positive and negative as well. And we've got 200 mega ohms there, so sounder circuit is all clear, that's good. Now zone 1, all clear to earth, and then all clear between positive and negative. Zone 2, all clear to earth, and all clear between positive and negative. So that's good. Now these ones obviously should be fine, but I'll do them anyway just in case. All clear. All clear. Good. Perfect. So I'll tidy these cables up, put some new earth sleeving on, neaten them up as much as I can, get the panel fixed in place, and then I'll go and connect all the various accessories. Right, so I've figured this out now. I was just really puzzled as to why they've run 2 cables to this, but essentially what it is one goes to the call point and then one comes back. So imagine, so it's on zone 1, this area, so that detector on the ceiling is on zone 1, which means that this call point needs to be on zone 1 as well. So what they've basically done is done it so that they can go from here. So imagine this is zone 1, it goes to the call point, back here, and then these 2 cables will just be joined together going out to the rest of zone 1. So it just puts this on part of the zone for the cable, but they're kind of using the panel as a junction box basically. It's a bit of a weird way of doing it, but it's fine. It will work, and it will mean that everything is as it should be. Just a bit of a bizarre way of doing it. So my good old friend Steve, who I just spoke to on the phone, he just talked me through a few little things. So I'm kind of confident about exactly what I need to do now with the end of lines and stuff. So I'm just going to get this panel on the wall now and then start wiring up all the detectors. Right, so I've got a proper fire alarm spur on here now, and it's got a key switch, so you can switch it on and off like that. And then the fuse is a 3 amp fuse, which is what's required by the panel, so that's all good. Basically, this, according to fire alarm regulations, needs to be a double pole, which it is. The previous one was just a single pole, and it wasn't actually lockable. It wasn't tamper proof, which is supposed to be, so this fulfills the requirements of the regulations. Right, I've managed to get this in. It's a nice tight fit, so that's good. So I've just got to do a few screws just to fix it back. Obviously I'm going to have to just fill this in, but that's turned out fairly good. There's not a huge gap, so I'm just going to put some decorator's cork in there and that will seal that off and it'll look fairly neat. And then I'm going to start doing all the end of line devices, well, doing all the devices in general, so going and putting the detectors on and the cool points and everything, and then I'll connect this panel up at the end. Right, so what I've done is just decided to label these cables up so that it's very clear what they all are, and that just does a nice, neater job for future maintenance. So that's labelled. Now I've spoken to my mate Steve about the sounder situation, and he said because I've got a sounder beacon base to go in here, I don't actually need to put a sounder above the panel on its own circuit, because that will act as a second sounder. So that's great, that saves me putting in a new bit of cable and mounting a sounder up here. So now that these are, I'm just going to sort of neatly dress these into place. I don't think I'll connect them yet to the panel until I've done all the various points, and then I'll connect them in one by one and test them as I go. Alright, so I'm gonna get these earths sleeved up, and I think I'll just put them together in a Vargo, and then I'll have to earth them off this little terminal there, because that seems to be the only earthing point on this panel. So the batteries go in like this, and basically they need to be cable tied in place, and this cable tie is provided by the panel. So I'm not going to connect the battery yet until everything's sort of ready at the other ends, but at least that's prepared, so that's easy to connect the battery in when I need to. So I might as well start with this first manual core point here, as it's the closest. So the great thing about these twin wire systems is they're just super easy to wire. So basically you just wire the L1s, which are the positives, i.e. the browns, both together into the L1 terminal, L1 in, and then you wire both of the blues or the L2s into the L2 terminal. And then there's a spare terminal which you use for the earths. So you connect those to there. And that's it basically. And you just click the head in and all good. So the only slightly different scenario is like this: when you've got an end of line, you do an end of line resistor. So I'll show you how to do that. Obviously we know this is the end of line because it's only got one cable. So we do exactly the same. So I'll put I usually put the earth wire in first. I'm not going to reach on this one, I might have to strip it back slightly more. So we connect the earth wire to the spare terminal as normal, but then these end of line resistors are supplied with the panel, and we need to connect that across L1 and L2, as this is the end of line point. So we connect L1 in as normal, but we also connect with it the end of line resistor, except when it doesn't grip in the terminal. So sometimes you have to double up the wire on these just to get it to stay in, and even then sometimes it doesn't want to. And then the L2 just goes in the L2 terminal as normal. And then to mount the detector head you just twist it on and that's done. Right, so I've just finished having a brew and having a bit of lunch, and I'm sitting outside because it's quite nice and sunny out here, enjoying that. It's going well so far. So basically the panel's in now, the zones are connected. I've just got to go around and put all the detectors on, call points, etc. I'm about halfway through now. So I've showed you a few of them already. I'm not going to show you every single one because they're all pretty much the same, to be honest. But let me know in the comments if you've got any further fire alarm questions. Maybe I can do another fire alarm video for you next time, because it seems like quite a lot of people enjoy these fire alarm videos. Yeah, so I'm just going to crack on really, finish my lunch and then try and get this all done. Right, so now it's the kind of moment of truth. Everything's connected in terms of detectors and all that stuff. Sounders, call points, they're all connected. So see, I've just connected the battery up, but I've not connected the mains yet. If I do reset, power supply fault should go away. Yes, it has, that's good. So I've just got to program it now basically, and they give you this key, so turn the key and then that lets me program it, and then we go to the instructions. Right, so I made a slight error here. I looked at the diagram on the back of the lid and it says that the end of line should be capacitors on the detectors and resistors on the sounders. So that's what I've done now. I've just put capacitor in at the end of line on the sounder, and I'll do the same over at the manual call point at the end of line on the other zone. And then a resistor needs to go at the end of the line on the sounder, and that's this little resistor here. Got some good info from a guy on Instagram. Thank you for that. I made a couple of little mistakes. So I put end of line resistors in on the detector circuits when actually it should be end of line capacitors on the detector circuits. and just shows you how you should always check. So this gives you the layout of the circuits basically, and it says capacitor at the end, and then for the sounder circuits it says a resistor at the end, 6K 8 ohm resistor. So that's why I had a fault come up when I first turned it on. So I've put my end of line capacitors in now. I've put the capacitors in the blank zones as well, resistor in the blank sounder zone, and what I'm going to do is do a battery load test just to see the various loadings on the battery to make sure that the battery capacity is adequate. Right, so it's telling me I've got a fault on zone 1 still, so I'm not sure what that is. Right, so the panel is all up and running and not in fault anymore, and I made a few schoolboy errors that I want to talk to you about. So the first one was putting end-of-line resistors in the detection zones instead of end-of-line capacitors. They provide you with both resistors and capacitors in the bag, but the capacitors in this case go on the detection zones and the resistors go on the sounder zones. So that's something to bear in mind. Another thing that I forgot to do is put the end-of-line resistors in all 4 of the sounder circuits. So before I was getting a sounder status fault, it was because I didn't realise that there was actually 4 sounder zones, and so I had not put resistors in these 2. So I've done that now, and everything's working as it should be. So I'm just going to run through some tests. I'm going to do a polarity test on the circuit, and to do that what I have to do is remove all the heads on the zone and then activate the manual call point, and that will tell me if the polarity is correct, because an end of line manual call point should still activate the system even when the detector heads are removed, but if the polarity is not correct then it won't do that. So just a little check that I'm going to do in the main hall. Here it doesn't actually matter because the call point is the first on the line, but in the main hall it does matter because the manual call point is the end of line. So yeah, nearly there. Good morning guys, Jordan here from Artisan Electrics. Welcome back. So it's day 2 of the second phase of the Scout Hut install. Fire alarm panel's all done, and everything's working as it should, so I'm pleased with that. So I've just got a few finishing touches to do on that fire alarm system, and then the main jobs here today are just to do a few lighting alterations and recess that socket in the floor just so that it's flush. So I'll show you what I've got to do here. So I'm going to change that light just to match with the other one that I put on this side, because the customer just asked if I could do that. I've got the lights in here, these 2 toilets to change now as well, because they are not really working, they're just staying on all the time. So I'm going to put these new BT14s with microwave sensors in there too, just to sort that out. A little finishing touch on the fire alarm system that I've got to do is here, where these cables are just sticking out of the ceiling. I'm going to just put a surface box on there with a blank plate so that those cables are protected and whatever. That's on the sounder circuit, but it's not necessary to have a sounder in here. So I don't know why they've wired it into there, but I'm just going to blank that off and then that'll sort that out. And then in here, I've just got this floor socket to recess in. So some of you mentioned it in the previous video, basically that it sticks proud slightly, and obviously that's a bit of a trip hazard for people when they're playing around in here. So what I'm going to do is just get my multi-tool on it and just recess it in slightly so that it's flush with the floor, and then hopefully that'll be a bit better. So yeah, should be a fairly easy little day, but you never know. Let's see how we go. One of the things I've got to do on here is just label up these zones. So there's actually only 2 zones. So I'm going to just label those zones 1 and 2 with my label printer. And then I've got a zone plan that I've got to make for this, which I will send over to the customer and they can get it printed and laminated and put next to the panel. But basically what I'm going to do, I use this website called Floor Planner, so it's free and I can just use that to make a floor plan. But I've got a little laser measuring device that I just got to run around here and just take measurements of all the rooms and stuff, just to get a rough kind of layout drawing done. It's not really that important, the actual dimensions of the room, but I've got one of those little Stanley like laser measurers, so it's super easy and quick to do. Yeah. If you enjoy my video, as always, hit a thumbs up and don't forget to subscribe if you haven't done so already. Right, so I've changed this light to match the other one, so that's all sorted. I just noticed that this emergency light is actually not working when I turn the power off, and it's just the only old fluorescent style one in the whole place. So I'm going to just change that over as well while I'm here, just a little freebie for them, just to sort that out. And then I've done these two lights in the toilet here, and what I also noticed was that they were coming on a bit too soon, like when you just walk around in the hallway here. So I've changed them to like a 10% microwave sensor pickup area rather than before when it was on 100%. So it's the same in here now. For the fire alarm, I'm waiting for a white cap to go on here. I'm just waiting for CEF to deliver it, and I don't think it's going to arrive today, which means I'm going to have to come back, which is a bit annoying. So now I'm just going to put the blank plate on here, and then that's done. And then I'm going to go and chase the socket in. Right, so you probably watched the nightmare floor socket video, and it was a nightmare job. But I'm back, so what I've got to do is just recess this into the floor slightly. Because the socket it's not very thick, but it's a little bit thick. This was sticking proud of the floor, and they can't have anything like that because it's a sort of gymnasium floor type thing. So I'm gonna just use my multi-tool. I've drawn a line around it here, and then I'm just gonna multi-tool it out, just recess it slightly into the wood, so that it sits flush. And I'm going to change the way I fixed it back as well, because at the moment what I did is I fixed the back box back, and then in fixing that back it holds the wood in place, but the wood is still a little bit wobbly. So what I'm going to do is actually unfix the back box, and I'm going to put 4 screws into the wood to fix the wood down, which I'm going to countersink in so that they will sit flush as well. Done now, so I recessed the screws in here. I fixed the back box either side into the wood, so this whole panel can just be lifted up by moving these 4 screws. And then this socket now is nice and flush, and you can still get in and lift the flaps up. So yeah, much better. Right, so I've labelled everything up, and now what I'm going to do is do a polarity test on the main hall detectors. So what I've done is removed the heads, so that's what I was saying, there's a fault at the moment. And I'm going to go and activate the call point over there and see if the call point still sets off the alarm. If the polarity has been wired up correctly on the alarms, then it should set it off. Whew. Okay. So to reset these call points is very easy. You just use this key that's provided, turn it, that resets them. You're supposed to have these covers, if it's recommended anyway, just to stop people accidentally triggering them when they lean on them or something. So I'm going to put these heads back in now. And I'm going to do a smoke test using the canned smoke on one of the smoke detectors. So I'll just go over there and just do a quick burst. And then should see it come into alarm. There we go. Right, start again. So after much head scratching and puzzling and umming and ahhing, I realised or discovered that the wholesaler gave me the wrong detector heads. They weren't alarm sense heads, which they should be. So we had weird thing going on where half of the detectors, when I smoke tested them, only made the panel bleep but didn't actually send it into alarm. But anyway, I've managed to get the correct ones now. So I'm back here and I'm just going to do another test. So hopefully it should work correctly this time. Let's do this one. And you'll see it light up. There we go. And then the panel will go into alarm. There we go. And the beacon base is not flashing. Let me just check to see if it does actually flash. Yeah, there we go. Yep, so it does flash, so that's good. So what we need to do is just press the reset button. That will get rid of the fault. Well, it's not a fault, it's a detection, but that's all cleared now. And basically I just go around and do that with all the various detectors. So do the same in here. Hello. Let's try one of these. That one works. I don't know why that other one's not working. Oh man, this does my head in. I hate that noise. Drives me into a wild panic every time. Anyway, that's good. So the only one we need to figure out is this one. Why is this not working? Oh, there we go, it is. It was just being a bit funny. Good, so that's all the detectors working. Few spares done. Cool points are done, they're tested, they're working. Right, that is me done, finally. Scout hut finished. Fire alarm panels all up and running, everything's working fine now, it's all tested and done and dusted. The zone plan will be attached here by the customer. I've just got to finish it off and get it printed and sent over. Emergency light up there has changed, so that's all good. Oh, rubbish. I need to put that back in the ceiling. Oh, never ends. Right, downlight is back in now. Oh, this job has just been never ending. Sounder beacon base. Sounder, detectors, blah, blah, blah. You know, I've shown you. Oh yeah, the blank plates on there, so that's done. Detector. And yeah, you know this place. Socket is recessed into the floor. Lights are all changed. We did it. So, thank you all for watching this epic series. If you haven't watched every episode yet, there are, I think, 9 of them, including this one, maybe even 10. Head back in the description of this video, you'll see a link to all the various episodes. Particularly interesting, episode 1, the introduction and the nightmare of stuff that was going on. Episode 2 is a consumer unit change, which is a bit of fun. Episode 3 or 4, I think, was lighting, fault finding, and that was just a nightmare. So, and if you want to see the episode about the original inspection of the fire alarm system, I think that's episode 7 or 8. Go and check that out. As always guys, thanks for watching. I really appreciate all the support on my channel, and if you enjoy my videos, feel free to hit the thumbs up button and tell the YouTube algorithm that you like my videos. And also, if you haven't done so already, subscribe to the channel, because then if you hit the notification bell, you'll get notified when I post a new video and you won't miss out on any new content, because at the moment I'm posting like 3 videos a week because I have nothing better to do with my life. Thanks for watching and have a great day.